Hey everyone, welcome to our Facebook live stream of the RS5 ADCP. We're just going to give a couple minutes for people tuning in. And meanwhile, Chris is going to show you the beautiful site that we're at. Okay, so for those of you just tuning in, hi everyone. Thanks again for joining us for the Facebook Live event, the second ever live demo of the brand new RS5 ADCP from SonTek. Now, the first ever demo was just this morning, so you're not too far behind. It was the same thing, but on Instagram. So today we are here. I'm Xue Fan, application engineer at SonTek. We are joined by Dylan Bedortha, who is the U.S. Northwest sales rep. And then back here we have Michael Sundman, who is a U.S. Southwest sales rep. And then behind the camera we have Chris Irasi, who is the SonTek marketing manager. So again, welcome. We're going to be showing you a live demonstration of SonTek's brand new RS5 ADCP. We're here broadcasting live to you from the beautiful South Lake Tahoe. And for those of you who aren't really familiar with the area, Dylan's going to show a map right here. So we've got the south part of Lake Tahoe shown right there, and we're actually at a site south of that, just about right here. Now behind us we have the Upper Truckee River, which is actually one of the primary sources of water flowing into the Lake Tahoe. So as we look downstream this way, all of this water is actually flowing to Lake Tahoe. So you can probably imagine that this area is very popular for fly fishing. There's quite a bit of different species of trout, and so the water management here in terms of stream flow gauging is quite extensive and important. We're also experiencing a year of severe drought again in California, especially in this region. And so in terms of water resources, we're also in a region where it's very important to be monitoring the stream flows here. So today we're actually at a USGS gauging station, and in this area there's quite an extensive network of USGS gauging stations. And just back behind me here, you can see the actual gauging instruments. There we go. And we chose this site because we wanted to compare discharge measurements with our RS5 to a known and trusted gauging station. So we're lucky enough today to be joined by a couple friendly beavers who have built a beaver dam off in the distance there, so I'll mention that in a bit. But for now, I just wanted to go over what you'll expect today in this live demo. We're going to go over the basic RS5 packages that you can order and what comes in the box. Once we show you that, we're going to show you some various GPS options and things that you can do to upgrade your system if you want that. And then we're going to go over some site selection, rules, and talk about the measurement method, which is the moving boat method that we're going to use today. And then we're actually going to show you a live stream demo of a data collection measurement. And we're going to show you the RSQ software on my laptop, which is meant to go with the RS5 system. And then we'll wrap it up by showing you, again, some of the components and some information about the site. All right, so let's just get right into it. So Dylan's going to help me out and demonstrate some of the parts of the kit that you'll receive. So with the basic RS5 package, you're going to receive things that you see in this Pelican case. So the RS5 ADCP itself is right in the middle, which Dylan's going to grab. It's going to come with a protective cap there that you can just take right off. And if you look at the transducer head, you'll see 5 different transducers. And this instrument pings at 3 megahertz. And this is actually a very unique instrument for SonTek. It's going to be the first SonTek instrument that incorporates a full broadband capability. So with this broadband capability, we've been able to really improve the Smart Pulse algorithm. And so it's really honing in on the best measurement that you can get for what we're targeting for this instrument, which is shallower streams and sites like the one we're at today. So again, back to these 5 beams. The middle beam is the vertical beam, and that's going to give you the depth measurement. And then we have those 4 skew beams around it, and those beams will give you the velocity profiles as well as an average depth measurement as well. So every instrument's coming with a temperature sensor, which is on the cap there. And internally, every system will come with a magnetic compass. And so if you're using GPS as your track reference, which I'll get into just in a little bit, you will automatically always use the magnetic compass for heading. But even if you're not using GPS, the compass will come in handy when, for example, you want to take a stationary or station-by-station measurement, which I have to mention is not quite available yet, but will be coming available very shortly. Or if you just want to take a moving bed measurement, which is a loop or SMBA test. So you'll use that compass for those things. And then on the back side of the ADCP, you'll see the battery or power cap. And Dylan's going to unscrew that for you and insert one of the 2 lithium batteries into the system. Now these batteries are rechargeable, and he's going to point the positive side down and stick it right in there, and then screw on the battery cap. And when the battery cap is screwed on, you're going to see a little LED light shine, and that indicates to you that the system is powered and ready to go. All right, so you'll also see a couple connectors on there. The right one is the GPS connector, and the left one is for the radio antenna. So your kit will come with 2 of these radio antennas, and you have the option of sticking that radio antenna directly onto that connector, or you can use this radio antenna extension cable. And the reason why we provide the cable is even if you don't have a GPS, some people want to mount the radio antenna a little bit up above the water. Now, this system will communicate using Bluetooth to your laptop. And so with Bluetooth, it's very sensitive to bodies of water nearby, so it's attenuated actually. It doesn't go through water. And so the higher up you lift the radio antenna, the better or more reliable communications you'll get. So that's just one of those tips in the field that you can try if you're losing communications. So Dylan is actually going to mount the RS5 system with the antenna onto, and this is an option, the Hydroboard 2 Micro. Now this floating platform is made specifically for the RS5, and again it's an option. It can come with this carrying case right here, which is a backpack. And once the system is mounted inside, which Dylan is doing right now, this is literally all you need to take a discharge measurement. So some of you might be used to other systems, including the M9, which have extra battery packs and extra brains outside of the ADCP. This is actually a one-stop shop. Everything you need is in here at this point, and you're able to get ready and just start taking a measurement simply with this setup. So while Dylan is assembling that for us, I'll talk a little bit about some upgrades that you have options for. So the first is the various GPS options. I'm going to be showing 2 today. Firstly, we have the differential solution. This is a fully integrated DGPS solution for the RS5. This is called the geode antenna, and it's an off-the-shelf antenna that you can purchase. It'll come with this cable that goes directly to the RS5. And once mounted onto the hydro board, you're going to be able to get your GPS track reference with differential or DGPS quality. So I'm going to hand this to Dylan, and he's going to show us how to install that GPS. And while he's installing that GPS, I'll just have you pan over here to a system that we've already set up, and it's in the water ready to go with Michael. So you'll notice that the GPS antenna here looks slightly different. This is actually the second ever, because the first ever was shown this morning, the second ever viewing of SonTek's RTK solution. So this solution is very close to being ready for sale. It's not quite ready, but very close. And so we just wanted to show you data coming from it today. So we have the RTK antenna. This is the rover on top of the floating platform. And then back there to the right of Michael, you see the base station. So we've got the RTK base station, RTK rover, and again, that's an upgrade that you can have with your RS5 system. All right, so if we pan back over to Dylan, he has the DGPS solution set up for us on the Hydrobird 2 Micro. And so with this setup, we have this GPS stand that holds this GPS or any of the other GPS solutions that you're interested in. This GPS will basically be connected to the RS5 with this GPS cable, and you're ready and set to go to take your measurement. So once you're happy with your measurement and you're done at a certain site, you can simply take this setup and basically bring down this bracket using those knobs. There are some Velcro straps here that will basically tie down this bracket for storage. And these straps actually can double as something to hold down weight. So I want to mention that because the board and the RS5 together are designed to be ultra light and portable. But if you're in a situation at a site where, for example, you have really fast flowing water or very turbulent water, maybe very windy conditions, and you want something a little bit heavier, you're free to add weight and use these straps to hold that weight down onto the board. So feel free to try that out when you're out in the field. So Dylan has collapsed the GPS stand, and at this point you can simply stick this whole thing into the carrying case, and once you've zipped it up, you are ready to go off to your next site. So we've really put a lot of thought into the design to be able to make it quick and portable and snappy, even for people as small as myself, to be able to get in and out of a site and take a quick ADCP measurement. Thank you, Dylan. All right, so there you have it, the basic components for the basic package, as well as some GPS upgrades that are available. So in the meantime, Dylan's going to be off camera and he's going to log into this Facebook Live feed. So if you guys have any comments or questions that you want addressed, feel free to just type them down below, and Dylan will basically keep a list of those so that we can talk about them at the end of this live demo. So please type away. All right, so let's get started with some site selection and measurement methods for the moving boat method. All right, so again, we're at a USGS site today, and general rule of thumb when you're picking sites, you generally want to avoid things like logs or large obstacles in the water. Today, we're lucky enough, as I mentioned, to have a beaver dam downstream. Generally, agencies will follow sort of a guidance rule of thumb that you want to be 10 channel widths downstream of any obstacle and 3 channel widths upstream of an obstacle. Now today, we have to admit that we couldn't find a site that's far away enough from this beaver dam to meet those criteria. But on the other hand, this beaver dam has actually dammed up the water enough that the levels are high enough that we can actually take a good measurement. Normally the flows, again, this year are just super low for this region, and it's very hard to find a good site. So that being said, we will be showing a moving boat measurement today, and many agencies will follow USGS guidelines for moving boat. So what that means is, first of all, you want to spend 720 seconds on the water actively pinging and measuring. You also want to do transects in pairs, so out and back, and that's supposed to eliminate some of the directional biases that you might see. And then you want to basically take 2 sets of transects, so 4 transects total, out, back, out, back. And today we'll be demonstrating to you how to take a transect, including the starting edge and the end edge. So let's just get to it. I will start by logging into my laptop. And meanwhile, while I do that, I want to mention that before any measurement, we always want to do a compass calibration. And to do a compass calibration, if you're familiar with the M9 or the S5, it's going to be the very same process. We're going to use the software, which I'll show you in a bit, and connect to an RS5 and perform a compass calibration. Now, we've already calibrated the compass for the system that you see in the water today, but Dylan over here is going to demonstrate to you how to perform a compass calibration for those of you who aren't familiar. All right, so pretend that I've connected to Dylan's system that he's holding and I've hit start on the compass calibration dialog. Now Dylan has started to pitch and roll the boat, and he's making slow circular movements. And basically the goal is to make 2 full rotations in the matter of 2 minutes. So he's going to go pretty slowly and make these rotations. He's pitching and rolling a little bit more than what you'd expect during the actual measurement on the water, and that's just to take into account any sort of movement that would affect the compass. All right, so let's fast forward Dylan, and we're going to pretend that he has made 2 revolutions. Thank you, Dylan. And I've hit stop on the compass calibration dialog, and it's going to tell me if I've passed or failed. So we've already passed this compass calibration, as I mentioned before, and we're ready to go to start our moving boat measurement. All right, so Chris, why don't we come on over here and let me show you the RSQ software. All right. So for those of you who are, again, M9 or S5 users, you will pick up the software incredibly quickly because it is very similar. Now there's a long list of new features with the software, so I'll mention a couple of them. A lot of the features are available in post-processing, so that's after you do your data collection. And what's interesting about this software is that not only can you use it to take a measurement with the RS5, but if you are an existing M9 or S5 user, you can take those data files and post-process them in the RSQ software as well. So you can really take advantage of those new post-processing features that we've put in. All right, so first things first, when you start a measurement, you're going to go through something that, again, M9 and S5 users will be very familiar with. It's the Smart Page. So there are a couple settings in the Smart Page that I did want to point out before we get started. And those include the magnetic declination, which is something specific to the site that you're at. And just make sure to look that up and input that into the software if you're using the GPS. So that really determines the direction of your GPS track. And when you input that, that will bring your tracks aligned to the bottom track. Something else that you want to make sure you measure and then input in the software is the transducer depth. So that's the depth between the water line and the bottom of the ADCP. And that depth is used and incorporated into your discharge calculations that the RSQ will report. All right, so why don't we just get started? I'm already connected to this system in the water. Let me just find my arrow here. There we go. And let's get ready to go with the start edge. So Michael is at the start edge. So we're looking downstream that way, and we're at the right bank. So we are going to select right bank. And Michael, can you estimate the distance from the bank we're at?
1.5 feet.
1.5 feet. I have to apologize for all you metric users. All right. So with the edge data, we're basically looking for at least 10 good samples and at least 2 good cells going down. So with the edge data, we'll basically take an average of all the velocity data at the edge, and that becomes one number for your edge value. So you really want to make sure that you have a good edge measurement to start with. All right, so we have more than enough samples here, and Michael, we are ready to start moving. All right, so Michael is going to slowly move the boat across the transect. And general rule of thumb for the speed of moving the boat is that you want to match the boat speed with the water speed. Now, obviously, in very low flows like we have today, it's not going to be very practical or easy to match the water speed. And so what most people would do is to basically take more transects. And in that way, you have more data to average out the variability that you might see in the low flows. So moving back to the software, I just want to highlight a couple different features in the software. You'll see a bunch of plots here which are fully customizable, and some tabular information that's also customizable. Again, RiverSurveyor Live users, this is going to look very similar. On the top here, we see the magnetic error in red and the vertical beam depth in black. On the next plot, we see the ship tracks, and I don't know if you can see at home, but the blue line here is the bottom track ship track, and the other lines are the GPS tracks. Now, what you want to look for in general is that the three tracks are collapsed onto each other, or as close to that as you can get. And that will basically indicate to you that you have a good quality ship track from all three of those sources. The bottom plot here is the velocity contour plot. And you'll see that as Michael moves across the channel, we see a little bit of noise when it's very shallow over here by the right bank. And that's expected because it is very shallow and the water is kind of stagnant actually right there. As Michael approaches the deeper end, we see some regions of higher flow near the surface and lower flows along the bottom. And Michael, just let me know when you hit the edge. We have reached the edge. So now I'm going to hit end edge. And what would you estimate the distance to be? 2 feet. Let's input 2 feet. And we are good to go for a left bank. And again, we're looking for 10 samples, at least 2 cells depth. And we have more than enough there, and we can hit finish. All right. So at this point, I did want to highlight a couple things in the data that will help you during your measurement to indicate to you the health of the system, the health of all the different data streams that are coming in. So as we start the measurement again, Michael, we're going to come back and make another transect. We're going to start with the left bank, and the RSQ software will assume basically that we're coming back. And so it'll automatically populate everything you need in order to come back. So we've started with the left bank, we've made the edge measurement, and we're going to move back. All right, go ahead, Michael. So as we're moving back here, Chris, if you want to come in really close, you'll be able to see these status icons. You'll notice that for me, they're all blue right now. So that means that we have good Bluetooth, good bottom tracking, good GPS data, good depth data, and we have an okay battery supply, and we have a good connection to the system. So everything's great. If you see yellow or red, that will indicate to you immediately that you should pay attention to those issues and hopefully correct them in the field before you go home. All right. So a couple things I did want to point out in terms of post-processing. Now, of course, this isn't the best venue for a post-processing live stream, so please do let us know if you are interested in a post-processing event, which we can do at a later time. In terms of post-processing, there's a very long list of new features that RSQ has, but I did want to mention that we have 2 neat features that you might be interested in. First of all, we have something we call beam switching, which is when you can force a 3-beam solution. So when this comes in handy, it's usually when you're butting up against some sort of vertical wall or obstacle where you have one beam that's being impacted. If those other 3 beams are still good, you can basically turn off calculations for that one beam and resume velocity calculations for the other beam. And in that way, you can preserve your data. So that's available, again, to M9 and S5 users as well in post-processing. Something else that might be interesting is what we call subsectioning. So that means that you take a transect and you can slice it up into how many slices you want, and the RSQ software will automatically calculate the discharge for those individual slices. So something to think about. And now Michael has actually reached the end edge, or the starting edge. And we're going to hit end edge, where I'm going to assume that we're 1.5 feet away again, and hit OK. So as the edge samples come in, we are going to wait for them to be sufficient, and there we go. And we're finished. All right, so we've taken 2 transects out and back. And of course, you'd want to probably do more, at least 4 transects, if not more, at this stage. But for the interest of time, we'll move forward here. I'm going to pull up here the discharge summary. And this discharge summary will basically list the discharge values for all the individual transects of your measurement And then it'll give you statistics. It'll tell you the mean, the standard deviation, the covariance, that sort of thing. So on top of that, you might be interested in the Discharge Summary report, which is a PDF report. Many agencies like to see that. There are various other exports, number one being a MATLAB export that can be automatic or manual. And that MATLAB export is fully compatible with QRev. So we've worked quite closely with the USGS in the development of the RS5 to make sure that the files are compatible with USGS's QRev software. There are also various other export options, Google Earth export options. There are other options to actually add site photos to the data file and also to add beam check files. Those are sort of diagnostic tools that you can use, and you can add all of those into the files. And again, this is not the perfect venue to do a post-processing event, so please email us at inquiry@sontek.com. That's inquiry@sontek.com. Let us know if you want to see some videos like that, or just put a comment down below and we'll record it. Okay, so that's what we've got for the RSQ software. Let me just read out some of the things that we've seen in the data so far that we've collected today. All right, so minimum depths, we've been able to hit roughly about half a foot in depth was our minimum over here. So that's about 20 centimeters or so. The system, the RS5 system, can actually go to as shallow as about 13 centimeters. So that's about this high. And then, let's see, for the deepest depths, we've hit just over 3 feet. So about a meter. The RS5 is actually rated to about 6 meters deep. So that's about 18 feet. So just keep those numbers in mind if you're looking for a system for your streams or your sites. All right, so with that, I think we'll wrap up today. I just want to kind of give a brief overview of what we've talked about. So we've talked about the basic system packages where you have simply the RS5 ADCP. That's, again, all you need to take an ADCP moving boat measurement right now. We will have stationary capabilities coming soon. We will have the RTK solution coming soon. And in the meantime, we do have the geode differential solution available to you right now. Again, we have the various boards, and just wanted to highlight the portability of these boards here. And so I'll strap this onto my back. And for comparison, this is actually the HydroBoard Max, which is the first board for the M9 or S5 system. And if you look at the size comparisons and the ease of use, I think it's obvious to everybody which one's the winner. Thanks, Dylan. Yep. I did also want to mention that we'll be coming out soon with a type of donut that will basically fit into a larger board. So if you're a user who has an existing HydroBoard Max or Mini, you can use the donut to put the RS5 into those bigger boards. You might want to do that when you have especially turbulent sites that are very fast flowing that can't be handled with this micro board. You can move up and use your RS5 in those situations as well. And then one last thing I did want to point out, you can also use the donut when it comes out with your RQ pod. So the RQ pod is Xylem's remote boat solution. And currently the hole is cut out for the size of the M9 or the S5, but you will be able to use this system with the RS5 soon once that donut comes out. All right, so that's about the material that I have for you today, and I think we'll have time to answer a couple questions that came up. Great.
We had 3 questions. The first one, Claudine asked, I think this has to do with third-party GPS compatibility. She said that they have an SX Blue 2 GPS, and she was wondering if they can use that with the RS5.
That's a great question. So in general, and that's something I didn't mention, in general, you can integrate a third-party GPS antenna into the RS5 system. Now, there are some particularities. You have to have a certain output rate and certain parameters that are output from that GPS. So as long as those criteria are met, All you need is a cable, which you do have to supply yourself. Many people will actually take our existing GPS cable and just splice it or put on a different connector. Right now it's a DB9 or serial connector, but if your GPS doesn't have that sort of connector, you're welcome to splice that cable and change it to whatever you need. Off the top of my head, I don't know the parameters or ability of the specific antenna that you mentioned, but we can definitely send you information on what's required to integrate into the RS5. But yes, in general, it is made to integrate into external antennas.
Cool. We have two other questions, two different Johns. One John asked, how shallow was the edge that we measured, roughly?
The edge here was actually, so the shallowest part of this site was actually somewhere right in the middle, away from the edge. And then once we got to the edge, it deepened out a little bit. So actually the edge was at about a foot deep, so just about like this. And the shallowest spot that we hit was about half a foot.
And another one was, I think we answered it, but what is the maximum depth that can be measured with the RS5?
The RS5 can measure depth down to 6 meters or 18 feet.
That was it for the questions.
All right, cool. Actually, there was one question that popped up this morning that I did want to mention because it was a very good question. It was a question regarding the USGS screening distance and whether or not we need to use a screening distance for the RS5. Now, with the M9, many users will tell you that you need a screening distance, and it's really due to the shape of the transducer head. You can see that it's very big, especially compared to the RS5 system. So with this large head, you actually have a lot more flow disturbance than with the smaller one. Now, the USGS has done a lot of extensive studies actually on the screening distance and the flow disturbance, and they've tested many ADCPs across the board, many different manufacturers, and they found that ADCPs that are shaped like this or very similar to this did not require a screening distance. Now, we haven't done those exact tests on the RS5, but because our profiles are so similar, because we haven't actually seen the need in the data to have a screening distance, we're fairly confident at this point that we won't need a screening distance for the RS5. But in the event that that does come up, that it will be required, then obviously we'll put that capability into it. So that was a question that popped up this morning as well. All right. Well, if there are no further questions, we'll just wrap it up for you today. Again, thank you for joining us. From myself, Xue Fan, application engineer at SonTek, Dylan, Michael, and Chris behind the camera. Thanks again for joining us today, and we hope to see you soon. Bye-bye.